Hello.
Hello.
Hi.
How you doing?
Good, good. How are you?
Doing well, doing well. All right, so you ready for a question?
Sure, yeah.
All right. So this is going to be sort of an algorithmic question, and there'll be a little bit of coding. So if you want to just pick a language that you are comfortable with,
Okay.
so for like algorithmic type of problems, I don't know if you've used the platform before, but there's you can pick from any number of different languages. Yeah, JavaScript will be just fine.
Okay.
So the idea here is that we're going to implement something of a scheduler, something that will help you schedule meetings in your day, sort of optimize your meeting plans for a day. And let's just say that the way it's going to work is that you will receive a list of meeting objects, and you will return the meetings that you should attend for that day. So let's just say you've got more meetings planned than you could ever attend, and now you have to sort of optimize that in some way, shape, or form. And I'll give you the different ways that we want to optimize it.
Okay.
So let's start by saying that you're going to write a function that is going to take in a list of these meeting objects and a number, which is the number of hours in the day that you want to have meetings. Mm-hmm. And you'll just return the subset of meetings that maximizes the total number of them. So let's just say that from my first pass, I want to just attend as many meetings as possible for that given day. And for each one of these meeting objects, let's say that you want to have all of these objects will have a name and a number of hours that they take.
Okay. So like this, a meeting object would be something like that?
Yeah, perfect.
Okay. And this is the function signature, right? That's written here. Is that correct?
Mm-hmm. Yeah, that looks good.
Okay. And I'm supposed to return the specific meetings that you can attend.
Yeah, as a list or something like that.
Okay. Return. Okay. So I mean, this sort of makes sense. For each meeting, though, all we have is how long it lasts. There's no mention of when it starts and when it ends.
So, right. So let's just say that all of these, it's sort of a contrived example, but let's just say you know that you want to meet with so many people during that day, mm-hmm. and you don't know exactly when they can meet you, but maybe you're really important. So you can tell them to start and stop the meetings whenever you want. And that all you're trying to do now is you're just trying to figure out how many you can get in and which ones you can get in. And don't worry right now about the start and stop times. So we'll just assume that if you're given a set of meetings with their durations, that you could somehow find a way to start and stop them. That's not so interesting from this perspective.
Gotcha. Okay. So that's fine. And the order that the meetings are passed in, is there anything special about that or?
No, they're in random order.
Gotcha.
You can't make any assumptions about the way that the order that they're sent to you.
Okay. So I mean, if I'm returning a list of meeting objects, it doesn't matter what order I return them in either.
Right. Correct.
Okay. Okay. So then, what it really sounds like is we want, like I said, we want to have as many meetings as possible with a given number of hours. So the approach that I would probably take is sort all the meetings by the number of hours they take, and then just pick the first have hours, number of meetings,
Yeah.
as sorted by hours.
Yeah, that sounds
And
good.
that gives us the most. That gives the most meetings.
Yeah, that sounds like a perfectly good way of doing it. So let's just code this up, see what it looks like.
Sure. Okay, so I'm going to sort this, and I believe sort can take a comparative function. I'm just going to look that up for a second. Is that okay?
Oh yeah, perfectly fine. Yeah.
Okay. Okay, so it takes a comparative function which returns -1 and +1. Okay, fine. So sort. Okay, so it's greater, return 1, or return -1. And we want to return 0 if they're equal. So if m1.hours equals m2.hours, return 0. Otherwise, if greater, return 1 or return -1. And that will give us a sorted meetings object. And then now we go through the list. And total hours will track how many hours we have met with people for. Oh, so here's my question. What would happen if, so you have, let's say you have 8 hours, right? And you have you have 3 meetings of 3 hours and then a 4-hour meeting. So would you prefer to return 7, I guess, or?
So, I mean, all we're doing is we're just optimizing based on the total number of meetings. And if, you know, in that case, you can only fit in 2 meetings. So that's the max. And you know, I have, there's no other criteria. So as long as it returns 2 meetings in that case, then that's correct.
Okay. Yeah, well, I can see an edge case where my method wouldn't exactly work, but you know, we'll go through that later. That's fine.
Okay. Yeah.
Meetings and not hours. So you start from 0 and then you return. So by the time we get to so stepping through the logic, so we have a sorted list of meetings, and it was a sorted number of hours. If we start off by totaling how many hours those meetings add up to, which is 0. And then at every step through the for loop, we check whether adding the next meeting's hours would take us over the limit. If it would, then you break immediately. Otherwise, you add it on to total hours. And of course, I also advances by 1. And then when you're done, the point at which you finished is the number of meetings that you could have, which is I.
Okay. But actually, if you could return the actual meeting object.
Yeah.
So you want to optimize. You want to maximize I, but you don't. But you actually want to return the meeting object.
Right, right. Sorry, forgot about that. That was called as meetings can be made. And we return that. Okay.
Okay.
So the same thing. It's now returned to specific meeting objects.
Looks good.
Okay.
So let's write a little test harness for this, and let's create 3 meetings of length 2, 3, and 5 hours, and run it through this and see what we get back.
Sure.
Actually, just for fun, let's try putting that in reverse order, just to see. So make it so here it says 2, 3, 5. Just make it 5, 3, 2, just so we can see.
Okay. And how many hours? How many hours do we have?
8.
8. Right. So it's going to fail for this, like I mentioned, because we're going to sort in ascending order, and well, actually, no, you'd still only be able to make 2 meetings.
Yeah. No, I think this is going to work. So let's fire it up and see what happens.
I have to run it up here. Okay. So yeah, it returned 2, 3.
Can you also add a log at the end with the meetings object, the original meetings object? Just afterwards, just so we can see what happened to it.
Like here?
Yeah.
Oh, well, I mean, it'll have modified the original meetings object also.
Yeah. So is that really a good idea? Like, is that might that confuse some people that they pass in some meetings and then the original object they passed in was modified?
Yeah. I mean, if that's undesirable behavior, one thing we can do is copy out the passed in list of meetings to another list inside the function. That's one option. And of course, that means we'd be using extra space. I don't know if that's acceptable. The other way would be, I guess the other way would be you'd go through the list of meetings, find the meeting with the smallest number of hours, add that on, then go through the list again, find the one with the second least number of hours, add that on.
Okay. Yeah.
That might work. That increases the time complexity.
Okay. Yeah. And actually, that was the next question I was going to ask. So, so you have the two options there. One was to create a copy and then sort the copy just like you did here. And the second is to go through and pick out the others, the other like the smallest, second smallest, etc. What are the time complexities of those two approaches?
So for the first one, the time complexity is n log n because the sort is the sort is n log n, and the search is just linear. For the second one, it would be n squared because you have the for loop outside, and then inside you're doing a linear search again for the smallest and the second smallest, and so on.
Yeah. Okay. No, that's perfect. That's perfect. Okay. So nice little warm-up problem. We did great. And now we're going to throw a little wrinkle in it.
Okay.
So this first time we optimized just based on the total number of meetings. And as you got it right, if you want to just maximize the total number of meetings, you just sort by the length, and then just pack them in a greedy fashion.
Yep.
Now, let's say I wanted to maximize the total number of hours that I was in meetings.
Okay.
So it doesn't actually matter how many meetings I attend. What only matters is that I'm in meetings for as long as possible during my day. So like if I have an 8-hour day and I can be in meetings for 8 hours, that's optimal for me.
Right. So you want to get you want to have the sum of the meetings that can be made to be as close to your half hours as possible.
Exactly.
Okay. Okay. Yeah, that is slightly more difficult. Let's think about this. So, see, one approach might be you start from the other end, and you take the biggest and add that on. But that doesn't really. Does that change anything though? Let me think about this. So let's say you have 8 hours and you have instead of 5, 3, and 2. Let's say you had, I don't know, like 2, 3, 4, and 5. And now you start from the end. Oh, okay. I think I sort of have it. Okay. So I think the approach here might be that you maybe use, so you still sort the array. And then you start from the end of the array and you look at the largest, the meeting that runs the longest. And you add that to your list of meetings that can be made. And then you go to the other end of the array. So like the start of the array. And you look for another meeting that, so rather you calculate how many hours you have left. So now let's say you've done 5 hours, right? So now you have 3 hours left. So now you're going to go back to the start of your array and search for 3. And you find the number that's closest to 3 without going over 3.
So what if, so I think I see where you're going with that. What if, in this case, you start off and there's 8 hours in a day, but your meetings are 4, 4, and 5.
Gotcha. Yeah. That's also a good point. What if you start at the other end? Then you start from the first meeting, and then you see how many hours you have left, and then you search from the end of the array. Basically work backwards.
You mean sort of like you did in the original one, where you sorted it and then you went up?
Well, sort of. So what I'm saying is you start with the first meeting, right? 4. And now you have only 4 hours left in the day. So now you scan from the beginning of the array and you look for another meeting that has 4 or fewer hours, or rather at least 4 hours. Do you see what I'm saying?
So and this is now a sorted. You sorted it first. Yes. Okay.
But it wouldn't work for the first example. So let's say you have, let's say you consider 2. 5, you need 6, and 5 is less than 6. That's not the ideal solution.
Right.
The ideal solution is 3 and 5.
Right. Yeah. Just starting at one end, unfortunately, is not quite going to get you there. It's close, but it's there certainly are some other cases that aren't going to quite work in a greedy fashion like this.
Gotcha. So I guess one of this isn't your. No, this is actually the class of subset sum problems. Except that you want to find out which. So the naive way to do this really would be you generate every single possible combination, and you see which ones add up to 8. And yeah, I mean that would be the naive way to do this. What's a better way?
Or do they? It's not necessarily. I mean, they don't always have to add up to 8.
Well, or as close to 8 as possible. So
right.
I mean, you generate all the combinations, you get their sums, and then you find the ones the one that's closest to 8.
Okay.
Going over it.
So let's yeah, I mean that will certainly work. And let's try coding that up. Let's just see what that looks like.
Okay. Sure. So write that out. Okay. So first we want combinations of one element, and then combinations of 2 elements, 3 elements, so on up to meeting start length elements. Okay. Okay, so now to get combinations of one element, we would do about this. Totally blanking here.
That's fine.
Yeah.
So think of it. I mean, you sort of had a good intuition at the beginning, where you were talking about. So if you think about all different combinations, you can sort of think of it as, you're looking at meeting like 1, 2, 3, 4. One of the combinations like either has the first one or it doesn't, and then the meeting either has the second one or it doesn't, and either has the third one or it doesn't. And if you add up all of those, then you've got the complete set of all possible meeting arrangements. Is sort of another way to think of it. I think you had sort of started to talk about it in those terms.
Yeah. Okay. I sort of ish.
Okay.
I mean, I've written a combination thing before. I'm just blanking right now. So no, it's not that. Okay, well, so at least please going to generate all the ones that have length 2, and hopefully that will get me somewhere. Okay, so this gets you all the elements with gets you all the combinations of meetings with length 2.
This is only going to return 2, right? Wait.
Yeah, that's what I said. So all the meeting combinations of length 2.
But there's 4 combinations with meetings of length 2. So it's either, well, I guess it depends on what you mean by length 2.
Well,
so this is going to return.
So let's say you had 2, 3,
meeting 1
So this would give you 2, 3, 3, 4. This isn't anywhere close to the actual solution. So
right. No, I understand. But
so, like that's what this would return.
I see. Okay. Yeah. Okay. It does do that. So that's basically saying all the possible combinations of two meetings.
Mm-hmm.
But let's see if I can give you a hint here about how you might get this to work.
Yeah.
If you think of breaking this down into subproblems,
mm-hmm.
you could think that given like that you have 100 meetings,
mm-hmm.
And you want to enumerate all of them, you could sort of break it down to say, well, I'm going to enumerate every way that I can permutate the first meeting,
mm-hmm.
and then append that to the list of what the maximum or what all the permutations of the next 99 are.
Mm-hmm.
So does that kind of help give you an idea about how you might do this permutation?
Yes. Sorry, remind me again. A permutation is order dependent or is not order dependent?
It's order independent, so
okay.
it doesn't matter the order.
Okay, so these are permutations, not combinations. Okay. Yeah. So. And there's no, yeah. So I understand what you're saying. So it's going to be something like, think about this. So for so this gets you everything from 0 to I, and then you add that to let's say I to the end. No, you want to skip I itself, so I plus 1. So this is basically what you're saying. So it's you want to get the permutations of all the elements except the element at I. And now when you get down to meetings dot length equals so basically the singular case. So if just return that, and maybe this also needs 1 for length 1, but I'm not sure yet. And I also want to push. So oh yeah. And you want to Okay, so what this is going to do is, can you see what I'm highlighting by any chance?
Yes, I can.
Okay, so what this will do is return all the permutations of meetings without the meeting at index I. And then once you have those, you add on the meeting at I to those permutations, and then you return the whole thing. Whereas if the length is 1, then you just return just that meeting object itself. So let's say you have right.
Well, here's a sample input to think about. So he says when the meeting length is 1, you just return that meeting. Now let's say that in the input set, I only have 1 meeting for that day.
Yeah.
But that it's greater than the number of hours I have. So let's say there's 1 meeting I have for the day, and it's 5 hours long, and I decide I'm taking a half day, so I only give it a total meeting hours, have hours of 4. So what's the correct answer in that case?
Just an empty array.
Right. So with this implementation, do you ever return an empty array?
Well, I mean, I'm not finished yet, though. I'm still. I mean, I'm still working out whether get permutations will return the entire set of permutations.
Or I guess so. From that perspective, if you say get permutations,
yeah,
on that meetings array,
mm-hmm.
Does that ever return the empty set, the empty array?
Well, I mean, right now I haven't returned anything. So as a preliminary step, you probably want to sort meetings and remove all the meetings that exceed your total half hours.
You could, but I think that's making it a bit harder on yourself, or the logic should be able to work even without that.
Okay.
Well, I guess what I'm saying is that if you look at these permutations, it seems like for any meeting that it's always going to return this meeting 0, whereas the permutations of all of these are going to either include or not include some meetings. So you see what I'm saying? That like you're always returning this meeting, and when looking at the permutations, you want to not include some of the meetings.
Okay. So in that case, though, get permutations will need to have knowledge of half hours.
Well, I mean, the permutations, getting the permutations, I like the way you've structured this, that basically you're saying, just give me all the different permutations of the meeting.
Yeah.
And it doesn't, at that point, you don't know what the half hours is, and that's totally fine.
Right.
But I'm wondering whether that's actually returning all of the permutations that you want to be looking at. So like, if you think of, if you're just given as the input meeting set, like meeting A with like hours 5 or something, what are you planning to get back? So meetings is an array of length 1 that just has that hours 5.
Yes. Okay. Here is how I see it. If you have a single meeting whose length exceeds the number of hours you have in the day, you could filter it out before you even get the permutations, so that you have fewer permutations to get through.
but or even I guess we could put it another we could phrase it another way and say, okay, if my two meetings are 4 and 5 hours, and I have a total of 8 hours in a day,
Yep.
then the 5-hour meeting is not going to be able to fit. So somewhere in this permutation, you have to say, well, the 5-hour meeting is not going to fit. It's not going to be in the set that I'm returning. And I guess what I'm saying is that the logic that I see here is always returning all of the meetings.
Okay. So you're saying that within get permutations, we check whatever we're about to return. Let's say, down here at the end, it's permutations without I. We run a sum on each of those permutations, and if any of them exceed have hours, then we maybe remove those permutations from the list.
Not exactly. How about we try this? I'm going to write a so here we have I'm going to put meetings 2, and it's going to have hours of 5, and console.log get permutation. So I'm just going to get all the permutations of meetings 2. So what are you expecting to see out of this?
I'm expecting to see just what you passed in.
But that's not all the permutations, right? So the expected result would be all permutations of one thing. So we want the empty set, and we want the so there's two permutations. It has the meeting and it doesn't have the meeting. Right?
Okay, I mean, I didn't consider the empty set as one permutation, but I suppose it's true. I'm sorry, I don't really understand the point you're trying to make here.
Okay, well, I guess I'm saying we can try running this this function and see if we get the result that you think we're going to get.
Okay, I mean, we can, let's give it a try.
We'll probably want to just like make that, but yeah. So we can try running it, and let's see what happens. Let's see if it actually returns what we think it's going to return.
Sure. So it returned just hours 5.
Right.
In fact, what we wanted was a list. So that's, yeah. So it hasn't returned an empty set.
So let's just start with that. Let's just start with the base case. That let's just make sure that with a lot of these recursive algorithms, you're dealing with a base case and then some recursive case. So let's just first get the base case down, and then we can work on getting the other cases down.
Okay. Well, so then if you consider the empty set to also be one of the permutations, then you'd append the empty set, or rather, oh no, wait, we have meetings. And that.
Okay, now we're cooking with gas. So that's exactly what we want to see. Now, if I add another one with hours 4.
Right.
So now our expected value is going to be hours 4 and then hours 5 and hours 4. All right. So there's 4 combinations of 2 things. So there's no meetings, just the 5-hour meeting, just the 4-hour meeting, and both the 5 and 4-hour meeting.
Yes. Okay.
So we know that your base case is working up here. So this part's working great. Now, can you think of a way to fill out the rest of the get permutations such that it calls get permutations on the next thing and still and still produces what we expect?
Okay. So you're saying not this.
Yeah, so I think that's a bit more complicated than you need, and I think that the slice of 0 to I think that you're iterating through the number of meetings and then calling get permutations on all of those meetings is then causing a little bit of problems there. I think you're calling the function, you're recursively calling it too many times.
Let me walk through this logic and think about it. So in the example that you gave, what is that? Well, yeah, let's assume it's this. So in fact, it should be, yeah. So if I equals 0, then we're calling get permutations on this slice. And then you go in, you're calling get permutations on this slice, and then you go and you get permutations on this slice. You come back up the stack. Permutations without I contains
So is that the right place? So you said that when you're given this length this length of 4 meetings, at that level, do you really want to be calling the permutation function for each successive length, or do you want to let the recursive call take care of calling shorter and shorter things for you? Because another way you can think of it as in terms of breaking down the problem into smaller units is I could say, you know, I have my first meeting and all the rest of the meetings. So what I want to do is I want to concatenate all of the permutations from my first meeting with all of the permutations of all the rest of the meetings. And that second part is completely handled by the recursive call.
Okay. So something more like, I mean, in that case, the recursive function would get the index of the element that's not being considered, right? So everything except I.
And then you can just pass in. So I mean, just think about how get permutations worked properly the first time. That it said given some set of meetings, it returned a set of all the permutations of that set of meetings. And it worked. Like and you didn't need any I, you didn't need anything. It just so this base case, it totally works. So if you think about if the length is greater than 1, then just think of it in terms of solving that problem for the first one, and then recursively asking the same function again to solve a little bit smaller function.
Right. I understand what you're saying. It's just I'm not sure whether that would work though. So you do one and everything else. Okay, fine. I guess that would work because so you just take the first. Fine. Get permutations. Okay, so this will get you all the permutations except for the first one, and then you. So in this case, at the second last level, permutations without I would contain that, and then to the next level, what you want to return is you want to return that. You want to return this. And that. So let's see.
So you're really close. So the first meeting is correct. The permutations without I is correct.
Yep.
It's just this last piece. You just a hint. You don't need to go through that list. So at this point,
well, I don't need to go through the list per se. What I need to do is join the first meeting to every other element in permutations without I, and then push it on to the end.
Yeah.
So push. J. Okay, so that, yeah, so onto this, so to the first element, we join first meeting, and then we push the result onto permutations without I. Now to the second one, we do the same thing, and we will get this, and that will probably work.
All right, let's hit go. See if that works.
That's fine. So permutations without I dot push. Okay, so there was something that was undefined.
I think if the spelling is different or something.
Maybe. No, they're all spelled the same. J lesson. Okay. So that's exactly what we expected.
Yeah, no, and you got the right idea that for each one of those, you want to push on hours 5. So copy this, and then on each one of those you have, I think maybe the problem, I'm not that familiar with JavaScript, but the problem may be that there's some weird recursive thing going on with this permutation without I pushing onto itself, which is pushing onto itself. I'm wondering if there's something that's weird there, and that maybe there's another way of doing that.
Maybe just do that. Let's see. It's logging a 2 somewhere, which is not quite what we wanted, right?
Permutations without I, J. And the 2, yeah, the 2 is a bit problematic.
That gives, okay, so it has a, why does it have a 2? We've clearly pushed a 2 somewhere in the past.
Permutations without I. Is it something about the slice? So you've logged the permutation without I is just, I mean, it's obviously the length, right? But I wonder why that's actually getting the length out of it. It's kind of strange. Because permutation without I dot length is 2, right?
Yeah. Storing the length somewhere. Let's see. No, it doesn't look like it. So the first meeting is exactly what we expected, and we do push.
So is there a way to copy the entire, I'm just thinking about a simpler way of thinking of it logically, that you copied the entire list that you got back, the permutations without I, and then in front of each one of those, you add the first meeting, kind of like you're doing, and then concatenate all of that together. Is there a way to do that? I don't know. Because yeah, I think you've got the logic basically right here, but there's something weird with the code.
I'm just going to try rewriting it. Make that, like what you said, might be a possible approach. Okay, so that's exactly what we expect. And first meeting is also what we expected. And you know what, let's rename this while we're at it. This is ridiculously long. And yeah, so since you said that like copying might be a problem, let's just make, oh yeah, but that's,
I mean, eventually if you're returning all of these, then a certain amount of copying is going to be necessary.
Pretty much. I mean, that's going to necessitate another loop inside the, so like I think what you're saying was happening earlier, because this is like an array of arrays. If you try and push something onto an array inside of another array and then push that back onto the array, it's going to cause it.
It's getting confused a little bit, yeah.
So let's just copy it out.
So there's no like array copy in JavaScript? I'm not that familiar with it.
Yes, ES6 might have it. I don't know the library function offhand if it exists.
Well, I think if you just say slice with no operator, that makes a copy. So slice with no arguments, that'll make a copy. Yeah.
Not quite what we wanted, though, is it?
Not quite, but it's getting close. If you think about it, you're going to create a variable that's going to contain all of the permutations. So you can just create a new one at the very beginning. The sub permutations, right? Yeah, there you go. Well,
what happened there?
Oh.
Quit.
Yeah, it doesn't like it. Copied. We pushed the first meeting. Oh, yeah, that one's looking. Oh, it just keeps going.
Okay, well, that's mystery solved. Something else is going on.
Something else is going on indeed. Wow.
So are you sure calling slice without?
I could be wrong, but seems like see a Stack Overflow answer that says it does. I'm afraid I don't. I'm not that familiar.
It's a shallow copy of the elements from the original array. I wonder if a shallow copy means it copies it copies object references into a new array. So since we have an array of objects, that's still not going to work. We have to do what I did earlier.
I see. Oh, I know what's happening. No. It's because you're increasing the length of permutations. And so when you say permutations.push, you're increasing the length of it. So I is just going to get bigger and bigger and bigger. I think you need another array that's called like all permutations. And then you should push all of those.
All right, fine.
Yeah. So it's the problem is or you could check the permutations.length earlier, and that might be simpler. That you could just check the total permutations length, and then make sure that I is yeah.
Okay. Let's see if that works.
You actually have to set len.
Oh, oopsie. Thanks.
Yeah.
Okay, so copied and then push meeting and then permutations are push copy, return permutations.
All right.
Okay, finally. Okay, so that did it. And now for the second part of the thing, which is and we want to do a sum. Just looking at the documentation. Okay, so the initial value. Do we have to return all the different permutations of meetings that are exactly equal to have hours?
No, just return the one best permutation.
So
and
yeah,
it might not be. It's the optimal one, which might not necessarily be have hours. It's the maximum number that's less than have hours.
gotcha. That's true. If yeah, if the difference if less than equal to have hours and so if sum is less than or equal to have hours, and we want to check whether sum is closer to have hours than closest sum is. So minus sum less than have hours minus closest sum, then closest sum with sum of meetings equals permutations I.
All right.
Yeah. Okay.
Let's see.
Oh, let me initialize that.
All right. So yeah, let's call optimize meetings with our meetings 2 and or actually with meetings and 8. See what happens.
So sorry, which ones? What
just give it this meetings as input. This one here, just meetings.
Oh, that. Okay.
Yeah, and have hours of 8. Let's see if that. See how that does. So, oh yeah, there's some extra log stuff in there.
Empty set and 8. That is exactly what we wanted. No, it isn't. Not yet. Okay. Let's look at this again. So we have get meetings. Sorry, we have get permutations. Let's check if we actually got the right permutations. Yeah, so the permutations were correct.
Yeah, permutations are good.
Reduce. Check.
I wonder if the sum is. Can you log the sum?
Sure. I was checking about the correctness of my reduce function. I guess logging sum would be a quick way to do that. Aha. So there is something wrong with my reduce. Okay. Wonder what that is. Sum is 0. Person meetings written. Why does it log two different things?
I'm trying to think. So it's a callback and initial value. And callback
contains the previous. No. Yeah,
four arguments. Oh. Takes 4 arguments: previous value, current value, index, and array.
I got it backwards.
Looks like you need 4 values to.
You don't have to take all of them if you don't need them. We don't need the index or the array itself.
Okay. Oh yeah, previous value and current value should be fine.
Okay, so now it's definitely logging the sum. So there's probably something wrong with my if. So if sum is less than equal to half hours, command
Sum equals sum. Can you log the permutations of I with the sum? I mean, I think that should. Oh, I guess yeah. It's 2, 0, 5. Okay, no, that's looking okay. So we're getting really close.
Yeah, I'm going to take out this console log.
Yeah. And now.
Okay. Why is it logging 8 though? That's strange. There's no reason for it to log 8.
That's true, yeah. So once you at each iteration, can you console.log optimal meetings to see what's happening there?
Okay.
Does it ever go into that if statement?
Doesn't look like it. Yeah, it doesn't look like it ever goes in. Yeah, so there's something wrong with this, with the if. I wonder Oh, something.
Half hours is undefined.
Okay.
Oh, is that from where you call it?
Yes. And that's why that was a clue. It was actually logging 8.
Okay. There you go. Ta-da! All right. Excellent. Yeah. All right. So yeah, it took a little while, but you made it through, and now you have the optimal solution there. Very good.
So there probably is I imagine there's a dynamic programming solution for this also.
Mm-hmm. Yeah. So that's and the way it basically works is that you do in that case. You don't use a recursive solution. You just set up a table where you look back at the optimal solutions. So basically, it again builds on this idea of starting with a base case and then building out from the base case. So you sort of say, well, let's say that I have like 0 hours in my day and a whole set of meetings. And in that case, that is the base case where you say, well, my optimal solution is just the empty set because I have 0 hours.
Yep.
Then for the hour number 1, you say, okay, well, what if I have 1 hour in the day? Then what you do is you say, well, for each one of these meetings that I have, I look back that many hours and say, well, what's the maximum, what's the best way that I can fit in 1 hour from given all of them. So some of the meetings, they may be too long, so they're not even looked at. But if you have some 1 hour meetings, then they look back and say, okay, well, I just need to add that 1 hour meeting to whatever it was one back. And so the whole time that you're building up this array, you have an optimal solution for up to that many hours. So you'll have an optimal solution for 0 hours and 1 hour and 2 hours and 3 hours and blah, blah, blah. So that when you say, okay, now I'm at hour 16 and I'm looking for how can I best add on meetings of length, 4 and 2, then you basically just look back 4 and 2 hours from 16 in your array to say, well, which one of those gives me the biggest sum?
Gotcha.
It's a little bit intricate, but it's kind of a neat sort of trick there. So anyway, well done. You stuck with it. I like the tenacity, and in the end, we got like a real working program. So, did you have any other questions?
No, and thanks for walking me through it. Appreciate it.
No problem.
All right.
All right, you take care.
Yep. Bye.
Okay, bye.